Carlos being a long-time contributor of WebKit, has been here, I don't know, for almost 16 years contributing to WebKit and WebKit GTK and GNOME. In particular, he's been working a lot in the past few years in all this refactoring around the graphics architecture of WebKit GTK and WPE, the migration to Skia. We moved from Cairo to Skia for the 2D rasterization. And now the next step is also using Skia for the composition step. And Carlos will give you all the details on that. So Carlos, whenever you want.
Yeah, thank you. Thank you everyone for attending. I'm going to present the work we have been doing recently about reworking the compositor in WPE WebKit using Skia. So first of all, you can interrupt me at any time to ask any question. Don't need to wait for the end of the presentation. Just let me know. Otherwise, there will be hopefully time at the end for questions. So I'm going to first talk about the first switch to Skia in WebKit that was not related to the compositor, but just to have a complete picture of an idea of how the graphics pipeline works and how the compositor is related to this. So as probably most of you know, we switched to Skia. So what we had before the switch to Skia in WPE WebKit was that basically the layer 3 can have roughly 3 kinds of contents. Layers with tiled baking store, layers with content buffers, and layers with a solid color. So for tiled baking store, the main thread records the layer contents into a display list, and then we had worker threads replaying that display list into a Cairo image surface, which is a CPU buffer. And then on the composition, those CPU buffers were uploaded to textures that were passed to the compositor to be composited. For layers with content buffers, we already have textures that come from different sources like WebGL, video frames, and those are simply passed directly to the compositor to be composited there. And in the case of solid color, this is simpler because we just passed the color to the compositor, and the compositor paints that color directly with OpenGLES. After Skia, Cairo was replaced by Skia for painting these tiled contents only. The model is mostly the same when we are using Skia CPU backend. We introduced some other optimizations, but the whole idea is pretty much the same. But Skia allowed us to introduce GPU rendering using the Ganesh backend. So the main thread records the layer contents, but now using Skia specific API instead of a custom display list that we had with Cairo. So we use this Skia picture recorder, and the worker threads reply this list by drawing this Skia picture into a canvas. So for GPU rendering, this canvas, this surface, is Ganesh surface that is wrapping an external texture. So in composition, those tile buffers are already textures that were produced in the workers. So it was more or less replacing Cairo with Skia, but keeping the same model. But the compositor, in the compositor, we didn't change anything. The idea was exactly the same. The compositor iterates the layer 3 and paints every layer. So for layers with tiled baking store, every tile has its own texture that is painted. For contents buffer, the contents buffer texture is painted, and for the solid color, OpenGL is used to paint the color. So TextureMapper was what we used for the compositor. It was introduced a long time ago by Nokia for a Qt port in 2010. And later, mostly all non-Apple ports adopted this, GTK, WPE, cairo, PlayStation, EFL at the time. It basically contains a collection of shader programs to paint the content with different filters, transformations, etc. I have to say that performance is quite good. But the thing is that this the TextureMapper today is more or less the same we had then. It evolved, but no big changes there. So yeah, we have an old code that is currently mostly unmaintained. So new features like the blend modes were never implemented in TextureMapper, for example. The anti-aliasing implementation is quite simple. Same for clipping, that is kind of limited to rectilinear and rounded rectangles. And it also has compatibility issues with different drivers. So after switching to Skia for the tile rendering, we wonder whether it could be possible to switch the compositor to use Skia to take advantage of that we are already using Skia and that we are already using the GPU, the Ganesh backend, the GPU mode of Skia to take advantage of Skia in all of the good things that it provides. And we gave it a try. The main goal has never been to improve performance in this case. When we switched to Skia for tile rendering, the main goal was to improve performance, basically taking advantage of the GPU rendering mode. It's true that Cairo was also maintained, so it was also maintainability, but the main goal was still improving performance. This is not the case with the Skia compositor. Here, the main goal is to improve the maintainability. So the code that we had in TextureMapper to iterate the tree, compute the transformations, is pretty much the same. So what we are basically replacing is the part that paints the textures that we get from the different sources. In this case, using Skia instead of TextureMapper. So the textures are painted into a Skia Ganesh surface. And the main advantages of switching to Skia, well, as I said, it is maintainability, but why? Basically, we don't need to maintain all the shader programs anymore. We currently have implemented all of the features that we had with TextureMapper. We are not using any external shader program. So everything is using just the public Skia API. Also, Skia has a good amount of quirks and workarounds for different driver compatibility issues or things that work different in different drivers. So just by using Skia, we have fixes for those for free. We are getting better clipping and anti-aliasing. Now we have a clip of any random shape, and also different algorithms for anti-aliasing. Yeah, and well, even though the performance was not the main goal, it is still important. So we wanted to make sure that we could get at least the same performance we had with TextureMapper. So the initial performance was mostly the same, but it was worse in some specific cases. So I will now talk about the different features that we have implemented using Skia to, in some cases, add new features or improve the performance. So regarding filters, in TextureMapper, the filters were always implemented using an intermediate surface where the filter is applied and then that surface is painted back into the parent surface. With Skia, we can convert most of the filters. Basically, I think they're all of the filters except shadow and blur filter can be converted to simple color filters. And Skia can paint those color filters without using an intermediate surface. Basically, we set the color filter in the paint, in the Skia paint that we pass to the draw image rect, and we get the filter applied without having to allocate an intermediate surface. So for those cases where we can convert to a simple color filter, the performance improved a lot. Yeah, same applies to masks. There are actually two types of masked content. One is the image mask, where we are using basically an image to decide where parts of the layer contents are going to be painted or not, and also the clip path, which is basically a random shape geometry path. In both cases, we were implementing it the same way in TextureMapper. So even when we had a clip path, we ended up with an image representing this clip path to be applied as an image mask. So we had the mask layer that was added as a child of the masked layer. Then the masked layer needed an intermediate surface to paint this the layer contents first, and then the mask layer contents on top using a mask mode that we had in TextureMapper that was similar to the testing blend mode. And finally, the intermediate surface was painted back into its parent surface. Skia has APIs to do both things without having to use an intermediate surface again. In the case of clip path, instead of generating a mask layer with the image representing that clip path, we can just pass the clip path as a path object that the compositor receives. And then we can simply use SK-Canvas clip path API. This is quite simple and much more efficient because we don't need to render the mask layer and we don't need to use an intermediate surface at all. In the case of image mask, in this case, we have the clip shader API of Skia. The image needs to be painted, but in the case of Skia, we can paint this image only once instead of painting. In the case of TextureMapper, we were painting the contents of the layer and the mask on every repaint. Now we only need to paint the mask once, and every time we paint the layer, we reuse the catch mask image to create a shader that we can pass to the clip shader API. So Again, we don't need to use an intermediate surface, but we also don't need to paint the layer on every repaint. I mean, the mask on every repaint. And the mask is applied using clip shader instead of painting the image on top of the layer contents, which is a lot more efficient again. Yeah, blend modes. This is just something that we never implemented in TextureMapper, I guess, because nobody cared about implementing it. But after switching to Skia, we realized that implementing this was just a matter of setting the blend mode in the Skia paint when needed. So it was super easy to implement, and we decided to have this feature implemented. Yeah, that's it, painting. The way Skia Ganes bucket works is that whenever a draw operation is asked to a canvas, the operation is not sent directly to the GL, to the OpenGL context, but instead it creates a task that is added to a queue. And this queue is flashed either explicitly or implicitly by Skia whenever it is needed. And when this queue is flashed, Skia iterates all the tasks, and it tries to merge items to reduce the amount of draw operations that are actually executed by GL. This is quite good, and it works pretty well when the queue is short. But when we have a large amount of items in the queue, iterating all those items and check if they intersect to each other to decide whether to merge them, all that CPU work might end up being more than the actual work that needs to be done to just draw the GL operations directly, especially when those GL operations are cheap. And this is exactly what happened with some of the motion mark tests that we converted to use composited layers. So while I have to say that while working on this, we realized that we didn't have benchmarks to check if we were improving or regressing, because the performance in normal motion mark tests were just pretty much the same, because in that case it is just one layer that is painted. So normal motion mark is mostly about tile painting or canvas painting rather than compositing. So we decided to take some of the non-official or the other motion mark tests that in the HTML suite and convert them to use the composite layers. So we took the same tests, but adding 3D transform to make sure that all those features, filters, mask, everything happened in the compositor side. And there were some tests that were adding a lot of very small layers in which the performance was much worse. And it was because of this. But the Skia has an experimental API that it was actually added to Skia for when Chromium switched to use Skia for the compositor, that among other things, it allows to create your own groups of operations. So basically, the draw operations that the compositor does is basically draw image rect, also clips, but the main way of painting things, except for the solid color, is draw image, because we are painting tiles. And this API allows to create groups of images to be painted later in a single draw operation. So this means that for this specific cases in which we are having a lot of small layers, we can group them when the painting is compatible. If they are using different filters or things like that, it's not possible. But assuming some conditions, we can still group many operations for the same layers or for different layers. And then every time we need to flash this batch, we emit a single draw operation to Skia. That in the best of the cases, it ends up being just one GL command as well. Skia internally checks also the batches to make sure that it can be run in a single GL operation, but in the best case, it is just one GL operation. So we implemented this and we realized that we were actually improving those specific tests. Although it's true that we are not yet, I mean, we are much closer to TextureMapper in those particular tests, but still not there. So we will continue investigating. And the last feature that we implemented, it was actually this week or previous week, it is the deferred display lists. And again, this is not to improve performance, not necessarily. It is because we were using Skia in a way that it's not the recommended way. But with the TextureMapper compositor, we couldn't do it any other way. But now that we have the compositor using Skia, we can do the recommended way. And the thing is that the recommended way to do threading with Skia is to have one just GR direct context that is the only one using GL. But now we are creating one direct context per worker thread, and we are generating textures from those worker threads. So the idea here is that we use this deferred display list that is similar to a display list, but instead of recording draw operations, it basically converts those draw operations to the final GL operations. So the main thread keeps recording into a escape picture, but worker threads, instead of replaying that into a Ganesh surface, they replay that into a deferred display list recorder. So the tile is recorded into a deferred display list that generates a list of GL commands, but without using GL at all. And then in the compositor, we replay that deferred display list that emits the actual GL commands. Well, actually, it creates, as usual, a task that is added to the queue, but in the end, those operations, those GL operations, will be done only in the compositor thread. So yeah, the initial.
Carlos, sorry for interruption. You need to wrap it up. I mean, there's only.
Yeah, I know. This is the end. Yeah. This is the last one. Well, almost the last one. So just wanted to mention that in most of the cases, the performance of using the deferred display list is neutral, but there are a few tests in which it's a bit worse. Not much worse, but a bit worse. But yeah, maybe it is something we need to accept, but we will continue working on trying to improve this. So yeah, the current situation is that the Skia compositor is the default now in WPE WebKit main, not in the stable branch. TextureMapper can still be used by using a runtime setting, but this is a temporary setting just to have while we implement the Skia compositor to make it easy to compare both and check if a particular bug is because of the Skia compositor or not. or to compare the performance easily between Skia Compositor and TextureMapper, but we don't plan to keep this runtime setting forever. For the same reason, and because we had some small performance regression with the ferret display list, we also introduced an environment variable to disable the ferret display list while we are still working on it. So the plan is to first convert this runtime setting into a build option and eventually remove the support for TextureMapper. The current performance with batch painting and all the improvements that I mentioned before is much better in some tests, especially for the cases where we managed to avoid using this intermediate surface. The performance improved a lot. In some other tests, the performance is the same. And there are still a few tests in which the performance is a bit worse, especially those tests that are adding a lot of small layers. So we will continue working on improving the performance whenever possible, but we consider that current performance is good enough, even if it regrets a little bit. It's also true that we have reduced the amount of GPU that is used during testing. So somehow, even the benchmark score is lower. We are using fewer resources, so this is kind of an improvement as well. But still, even though we consider that the performance is good enough, we will continue working on improving whenever possible, and also taking advantage of Skia to implement other features like per edge anti-aliasing. And also, eventually, we want to switch to Vulkan. Thanks to Skia, this switch will be a lot easier because Skia has this graphite backend, which is supposed to replace the Ganesh backend at some point. And most of the API is mostly the same. It will not be a matter of changing one line to switch from Ganesh to graphite, but at least most of the API is the same because the SK Canvas API is the same thing. And that's it. If there's any question.
Perfect timing. Thank you, Carlos. So yeah, any questions here or remote? I think there's quite a bunch of people. Yeah, Philip. The one who's farthest away.
So about the TextureMapper, we had shader support there for the Qualcomm video decoder, and is there a way to do that with Skia as well, like set up a custom shader to use an EGL extension to render those buffers?
Yes. Yeah, do catch my little lie? I said that we, well, it wasn't a lie because we currently are not using any external shader, but we will have to use one for the Qualcomm video decoder that we haven't implemented yet. But yes, there's API in Skia to do that, and it should be quite easy to introduce.
Okay, thanks.
Another question here.
Yeah, hi. Are you also discussing with the Skia team for those performance regressions?
No, we are actually in contact with the Skia team, and they are helping us always. But for now, we haven't talked to them about the performance regressions. We are basically just starting, so we are trying to figure out ourselves the problems. Okay. But yeah, I actually talked to them before starting using the experimental APIs because I was afraid of those experimental APIs to go away soon. The same for the ferret display list, which is also kind of semi-private API in Skia, only used by Chromium. So yeah, I contacted to them before using those APIs, but not specifically to ask about why we are getting those performance regressions. We are also assuming that Skia has kind of more, how to say, I mean, in TextureMapper, we were using OpenGL directly, and it was specifically for composition in WebKit. Skia in the end is a general purpose API, and it usually has more overhead in some cases.
Thank you. Any more questions? Okay. Thank you, Carlos.